Alright, let's move on to factoring a trinomial. So in this case, we have 3p squared minus 2p minus 5. Okay, so the thing to note here is that we have, for a, we have a coefficient that's bigger than 1. But it works the same process though. So for example, we have to, if we want to factor, we make two binomials, right? So we take the first term, and we can say that this can be 3p times p. Because when you multiply this out, 3p and p, we get 3p squared. Alright? So now we have to work with the factors of 5. Now we have to be careful here because since we have a 3 here, we have to make sure that when you combine this 3 with the factors of 5, that somehow you have to get 2. So the factors of 5, well, 5 and 1, right? There's not a lot of options here. You can either put 5 here, or 1 here, or 5 here, or 1 here. Now if we put 5 here, what happens is if you use a FOIL method, it's going to be 3 times 5, that's 15. It's not going to be possible to get to 2. So it wouldn't be a good idea to put 5 here. So I would put 5 here and then put 1 over here, because now if we multiply 3p times 1, that's 3p, and then 5p, 5 times p is 5p. 5 and 3, if we combine together, we should be able to get a 2. So we should be able to satisfy this trinomial. Now, because we have a negative 5 here, where the signs have to be positive or negative, so it can't be two negatives or two positives, because this is a negative 5. Now the question is, where do we put the negative and the positive? Alright, well, we know that in the middle term that it has to end up being a negative term. So what we do is we have to think about when we multiply it out, 3p, 5p, we have to find out which one's the bigger number, because we're going to get a negative answer. So that the bigger number, that's where we put the negative. So we have 3p and we have 5p. Because 5 is bigger than 3, we're going to put a negative in front of here and then put a positive. So when you multiply it out, it's going to be negative 5p plus 3p, which is equal to negative 2p. So this is the final answer. Alright, let's try one more. Let's try 9k squared plus 66k, alright, plus 21. Now when you take this problem, what you want to do is, if we have a coefficient that's bigger than 1, we want to see that if we can factor out anything from these three coefficients. So the factors of 9 can be 9 or 1, or 3 times 3. Now you ask yourself, do all of these three numbers have a factor of 9? No, they don't. Do they have a factor of 3? They do. So you can factor out a 3, and if you do that, 9 turns into 3, because 3 times 3 is 9, k squared, plus, right, if we factor out 3 from 66, that's going to be 66 divided by 3, so that's going to give us something like 22, right? Okay. And then 21, if we factor that out, alright, that's going to turn into 7. 3 times 7 is 21. Okay. So now, what we can do is, now let's try to find two binomials for this trinomial. Okay. So, first term I can write 3k, and the second part here I can write k, because 3k times k is 3k squared. Alright, so now the factors of 7, well, just 7 and 1, but somehow when I combine this 7 with this 3k and write k, that we have to get 22. So I can either put a 7 here or a 7 here. Now we want to get 22, so if I put a 7 here, okay, then it's going to be 3k times 7, which is 21, and if you put a 1 here, you get 1k. So I think we're on the right track, because 21 plus 1 is 22. And because it's plus 7, we can either have 2 positives or 2 negatives. Now we know it's positive because if you look here, this sign here is positive, so the only choices really is to put 2 plus signs right here. And this is the final answer. 3 times 3k plus 1 times k plus 7.